was.
Yes, we were.
Hyperboloi? Anyway, just kidding. Hyperbolas is the plural of hyperbola. I heard someone yelling in the hallway about alumni and alumnuses and whatever.
Is it alumni singular or plural? Alumni is plural?
Yes.
Okay, alumnus is singular. I didn't.
Yes, that is true.
Okay, I wasn't sure.
It's okay. It's easy to get confused. Alright guys, we have some formulas to work with, and we have some examples to do. The nice thing is, let's not treat like chocolate. We have 1, 2, 3 examples and then homework. For the most part, you guys were pretty respectful towards the end. Attention span, we need to work on this. You guys can sit down and watch a Netflix movie. You can't sit down and listen to a person. You guys accomplish more than probably most of us will in our lifetimes as far as worldly recognition. And still stay close to Christ, I should say.
I can't sit still.
I said probably, and I said most of us. That's one, that's not most. E for effort, I think success. So, examples. Sorry, I don't say that as much anymore. Because I can't give you an A for effort, because everybody wants. This is not 7th grade. Yeah. You used to have citizenship, which is behavior, and then you used to have, oh my goodness, citizenship and there's one oh, what am I missing?
We had
Work habit. I think it's called work habit.
we had an actual grade for like the work, and then we had an effort grade, and it was on a scale of 1 to 4 for each
You should. There's actually multiple ones of us that have been talking this year, like we really need to do that. But that should be, because parents just see your grade, but they don't know how. And same for you guys to be like, oh, my teachers really don't think I work. Maybe I should actually put it on grade. Huh?
But participation is different than like
See, that's different. I do it mostly by you guys just like participating in class, which is what I want to do is always do fine participation. Only if you maybe dip lower, if they're not participating and they're like doing their own thing. But that's also kind of citizenship. But I would like to work out. Okay, here we go. That's random. Find the. I also like cursive in elementary. So find the standard form. That's an old statement. Find the standard form of the equation of the hyperbola. I think we need to remember the equation of the hyperbola. You guys have it up above in your notes. True?
Yes.
Okay. Should the x go first? The x term, x minus h quantity squared over, or should the y go first? Just from the clues. How do you know? How do you know?
You got it.
Ah, that's what I was looking for. They don't say horizontal, they don't say vertical, so we have to say, what do the clues tell us? What do the clues tell us? We have the point negative 1, 2. We have the point 1, 2, 3, 4, 5, 2. I think I see the 2 staying the same. How about you guys? 0, 2, and 4, 2. Can you tell it's horizontally oriented? Because it's going to be opening weight. The vertices are the edges of parabolas. And the parabolas have to eat the foci. Which way are these oriented? Outward. They got to go eat the foci, right? So, I'm doing something like approximately, something like this. If I'm doing something like that, then I must have the equation form x minus h quantity squared over a squared minus, because it's not an ellipse anymore. It's a hyperbola. So we need our y minus k quantity squared all over b squared equals 1. Someone tell me something that we can plug in.
Well, since we know the vertices, we can also find the center.
Ah, but they didn't give it to us. That's a dilemma, but we can find it. How can we find it?
By using the
Distance. I like it. The distance between the vertices is what? 4. You can subtract the x values if you want. Oh, sorry, those aren't the vertices. You can subtract the x values if you want. 4 minus 0 is 4. Or you can measure the distance and say, well, if that's 4, then where's halfway? At 2. So go over 2 and say, hey, what's this point then?
2, 2.
It's the center, and it's 2, 2. So therefore we can go ahead and plug in our h and plug in our k. So we know x minus 2 quantity squared all over. We'll get back there in a second. Y minus 2 quantity squared all over. We'll get back there in a second. Oh. Now what? Is there anything we can fill in?
A,
Why?
because according to the information in the visual, we have the quantity of A is the distance from the center to the base.
Yeah. So the center to one vertex, we found it because we had to find the half distance to get to the center. So what is the center to the vertex? What's that measurement? 2 there, 2 there. So A is equal to 2. Because it's the horizontal measurement. It's underneath the x. How do we know for sure though? No, it's
C.
C is 3.
C is 3, and then we can use
Because C is the distance from the center to the foci, right? Center to the foci, that would be 3. And then we can use the formula that some of you started saying. What is that formula again?
A squared plus B squared equals
A squared plus B squared. A squared plus B squared. If you want to think about it, an ellipse, C needs to be shorter because it's going to be within, so it's A squared minus B squared, whereas a hyperbola, the foci need to be outward. They're outside, they're further away, so there's a plus. I don't know, it's a silly way of, that's a visual way of remembering. Ellipse, it needs to be inward, so minus A squared minus B squared. Hyperbola has to be outward, so plus. So if I can plug in C and A, that's going to be 3 squared is 9, A 2 squared is 4. What's B have to be? B squared equals 5. Do we even have to do anything else? Do we have to do the square root and then put it in? Or can we just make a straight substitution and say, haha, sweet.
Straight substitution.
Just be careful you don't go 5 squared. Does that make sense? B squared is 5, so we substitute for B squared 5. Okay. So then to finish things off, they say standard form. You guys know we'd have to multiply and FOIL and move stuff. Can we just leave it in a nice crude form? Is that okay?
Yeah, I like this one.
She nice to me.
Let's just put over 4. She the vertex?
Who's she?
In case you guys missed the conversation. Alright. So we have the center, we have the A plugged in, A squared, we have the B plugged in, B squared. C was just a clue to help us get there. Without C, wouldn't we have been lost, guys? Alright, good to go?
Yep.
Ooh, only 2 more to go. I think we might actually finish, even
Oh
though
boy.
our class is a little shorter today. Ready, set, and? What are causes? Things just got a little more interesting then. But, can you guys learn from the last example and Sean's idea that maybe the first thing you should do with clues is graph them?
Yes.
That sounds smart, right? Okay, now I think everybody's gotten back in after softball, right? No, we're still missing. I'm not used to the new scene chart. Are we missing anyone?
No, this guy.
Yeah.
Yeah, no one else.
Okay. I don't see any other holes. So the people that are normally around you are around you, right? Yeah. To that end, the whole new scene chart thing.
Should we smile?
Make the seating chart. Can I get everyone? Aww. 1, 2, 3. Hi. You guys look appropriate. I gotta check. I smile. Luke is looking cool. Luke's looking a little creepy. I'm smiling. Alyssa's hiding. He's just smiling. Alex looks mad. Sean is writing diligently. What? Sean in action. Right there.
Can we just
Look at him
What I deal with every day. I know, you really are bullied. I'm so sorry.
Hands looking chill. Kristen saying, she's here.
Oh, you can see it on the computer.
Me? You can see the
Who's
pictures.
looking at us?
That's gross.
I look crusty.
Brandon looks a little bored.
I look so good.
It's so true. And then we thought that.
Alright, you guys got it? What'd you do so far? What'd you get? Anything? You guys graphed it at least, right? Or were you too distracted with the picture?
I was distracted with this last year.
Huh. There were a few reasons, but the last pre-calc kid finally made up their last chapter 9. Because some of your questions might be shared or similar, so I didn't want them out there yet. So you guys will get them back tomorrow.
Yay!
Wait, can we know what we got today?
No, I'm trying to finish scoring them. But you'll get it back.
I was like,
No, it's Thursday?
Yeah.
Hold on, we have an assessment coming up soon.
I'm in pain.
Our chapter 10A. I don't want to have to do the same day Jesse as the test. That's why I'm trying to check it out.
Wait, when is
Next something. Yeah.
Where'd it go?
Next Tuesday.
Wait, the chapter test is next Tuesday?
Then Wednesday.
Next Tuesday?
Yeah.
Next Tuesday.
Yeah. So we'll say next Wednesday. Maybe next Thursday.
No, we have ACT Aspire.
Okay, so since the ACT expires on Wednesday, your test corrections will be due on Thursday.
The what's the ACT next Wednesday? Is it the juniors?
It's sophomores and juniors, right?
The Terranova.
What is
No,
it?
the pre-ACT.
P-A-C-T. Oh, that's the most boring.
Alright guys, wait! Oh, I'm not even on the notes, so take it on here.
Why do I have to take the PACT? I take the ACT on Saturday.
Check out the calendar, it's been updated all week. Okay, so, pause, focus.
When are the test corrections gonna be due?
Wednesday.
Oh, I thought that was the test, the actual
The
test.
test is Tuesday, you guys have pre-ACT on Wednesday, and then the corrections are due on Thursday. Boom, boom, boom. Okay,
We don't.
here we go.
Dude, we just.
Okay, eyes on me, focus.
Okay.
You should look at your class calendar from time to time.
Probably.
Number 1. Number 2, I said that there's a 10-1, 10-2, 10-3, and another section. We're finishing 10-3 today. We're doing another section Thursday, Friday, review Monday, that's Tuesday. Normal. And you guys have been seeing your homework sheet. Hopefully you've been looking at it. We're almost done. So here we go. Vertices, -2, 1. It's better than the day after the pre-ACT. And 2, 1. So we have a point here, and a point here, Give me 1 second. Is there anything else that we can graph? Okay, so we need 1, 2, 3, 4, 5. Does that seem kind of random? 2, 3, 4. It's not a foci. Okay, just kidding. It'd be only 1. It's not a focus. It's not a vertex. It's not the center. You still have to use them. Hold on, pause. Question. I think sophomores and juniors.
Freshman.
Oh, just freshmen.
It's just freshman and sophomore, because we took it last year.
Okay, so only a few sophomores in this one. I remember. I remember it was 2 years.
Yeah.
All right, kiddos. Does the X go first or the Y go first? Sean, what do you think?
It would be the time.
It would be the X because, explain to us though, how come?
Oh, because by the way that the point looks, and if like, let's say if like the y-axis was like a mirror, it would have to come out so that the point in the hyperbola would have to go from here to here and pass like that.
So he's saying he thinks that this needs to connect. And if it connects that way, oops, undo. If it connects that way, this one's going to go that way.
Oh, okay.
And pass
And we're going to, yeah, it's horizontally oriented. But then, can't you also say anytime, what are these, the vertices? Anytime the vertices are next to each other horizontally, doesn't it have to go horizontal?
No.
Because otherwise, if it was vertical, wouldn't they be on top and then they'd have to bounce off that way? Does that make sense?
Yeah.
So, it does kind of help to think about how these two are going to connect. But ultimately, how do we know for sure, these two share the same y. So, horizontally oriented, the X one has to go first. I'm not even gonna set up the equation because we did it last time. X minus somebody squared all over minus, it's a hyperbola, x y minus somebody squared all over. Did they give us that center?
We can find it. We can find it on the ground.
Because it's halfway, right?
It would just be 0.
Yeah, you guys got it? Because the whole distance is 4, cut it in half and we'll end up at the middle. That's right. So then coming back, we have the point 0, 1 as the center, so we plug in the 0, we plug in the 1. Can we plug in A's or B's or any of that sort of stuff? Are you sure?
Yeah.
Okay, we can.
A!
A's too.
Oh, we don't know B though. Do we?
Yeah, you can just C squared.
Because we need the 1 underneath the x, because that's the horizontal measurement, the
Oh no, you
distance
don't have
is
a
2.
forecast, that's true.
So we need to plug 2 in. Because think, horizontal is going to go underneath the x, that's one way of remembering it. But vertical, that's the weird thing about hyperbolas. Vertical is what you do to go ahead and get the asymptote. It's not actually a point. Lucas said find the C, but they didn't give us foci.
Find the forecast.
What should we do? Sean has an idea.
Find
Luke, do you have an idea? What are we going to do?
Can't we use the point that they gave us?
Because that point, the 5 stands for what kind of value? X value, right? What does the 4 stand for? The y value. So we have an x, we have a y. Can't we plug in an x and plug in a y and get out a who don't we know? Now we have options. We could simplify first and then plug in. Or we could plug in and then simplify. What do you guys want to do? Simplify then plug in or plug in then simplify? Okay. So then if we plug in, we have the point, what was it, 5, 4? Okay. So we're going to plug in 5 into the x spot. Let's choose a different color. So we're plugging 5 in for x. We're plugging 4 in for y. Now we'll simplify. 5 minus 0 is 5. 5 squared is 25. All over 2 squared is 4. Minus 4 minus 1 is 3. 3 squared is 9. How do we solve this?
Should we square root both sides?
No.
Okay.
Killing a puppy. Because it would be a difference of squares.
Okay.
So it'd be 5 halves minus 3 over b times 5 halves plus 3
5
over b.
over 4 to the other side of the equation.
Okay, yeah, we can subtract. We can move things over. We could multiply both sides by 4b squared. But okay, we can
I wasn't sure about
subtract
that.
this guy over.
Or should we?
That's okay. This one.
Okay.
Now, we can't combine some things until we get a common denominator, true?
Yeah.
Alright. Negative 9 over b squared equals, what's 4 minus 25?
Negative 21.
Negative 21 all over 4. How do we simplify that?
Cross multiply.
Nice, I like it. So, cross. The only reason we're able to cross multiply is because it's an equal sign. We're solving an equation. Making myself a little more room. So we end up with, at the end of the day, multiplying up the b squared and multiplying up the 4 is ultimately what we're doing. Negative 36 equals negative 21 b squared.
So it's plus or minus 6 over square root of 21.
Yeah, because we have to divide both sides by negative 21 to get rid of that.
And then square root.
The negative over negative becomes a positive, then b squared is going to equal 36 over 21, which does mean that b is equal to, remember, we keep them positive, 6 over root.
But it's good to keep the root in the denominator in this case.
Yeah, so we're going to have to plug it back in somewhere else anyway, right? It's not a final answer. Because all of that was to find b. What's the point at the end of the day as to what they're asking? Find the equation. So we gotta plug and chug everything back in. Well, that's a bummer. Meaning,
Wait, can I ask if b squared equals 36 over 21?
we could just plug in b squared, right? So you can go ahead and come back to the beginning and say, alright, x minus 0 is just x squared all over 4. minus, we had y minus 1 quantity squared all over, Karina, say your idea out loud one more time.
Well, if you find b squared equals instead of simplifying then squaring.
Yeah, we can take what b squared equals right down here. And we can say, okay, let's just plug and chug. Let's not even worry about taking the square root of it, because we want the squared. So I'm plugging in 36 over 21. Let's see if you guys understand why I'm going to write 21 and 30. Oh, wrong way.
Wouldn't it be 21
Why I'm going to write 36 and 21.
because
When you divide by a fraction, you multiply by the so 21 goes up top, the 36 stays down bottom, and then we say, that's gross, but there you go. Dun, dun, dun. If we wanted to make it all written out in standard form, we don't want to keep the fractions, we don't want to keep the factored stuff. What would we do next? We're not going to, but what would we do? We want to put it in their standard form, the ax squared plus bxy plus cy squared plus dx plus
common,
dy plus f.
common,
Common denominator, we could do that.
and then
Or we could multiply both sides by 36. Or we could multiply him top and bottom by 9. We put those two together, right? We move the 36 to the other side. And then what would we simplify? We need a foil. Foil, move it all back to one side, and then we're done. And it would look something like, drum roll please. Yay!
No.
This one.
Ooh, that's ugly.
bruh.
Ah!
No.
It's okay, so I got a drum roll. Okay.
Do we have to do the complete the square thing on this too?
Jingle bells.
I don't mind.
Drum roll.
Break it fun. Sweet on the
It's becoming go.
What do we do with the crazy?
Subtract 63.
Yep, that 63 is not gonna work. No, we've done this. We've done this.
Okay.
Move that 63. Okay, move that 63. Okay. What else?
Oh, there, 69.
Group the like terms.
Group the y's with the y's and the x terms with the other x terms. So I'm gonna. What should we put first? The positive one, right?
Yeah.
So are the x terms gonna start with a positive, or the y terms gonna start with a positive?
The y.
Yeah, so we're gonna put the y first. Maybe it's one of those other oriented ones. Why am I pulling a 16 out?
Because you can.
Because I can. It's one of those typical. How many times 16 going to 64?
4.
Minus. There's no common factor, but why did I pull out a minus?
Because and then you say it's positive. I
It's
guess.
a formula, right? Doesn't the formula say something squared minus something squared? So I'm pulling the minus away from the x squared, plus complete the square, and not allowed to have the negative in there. So is it going to be plus 2x or minus 2x? Nice. Good catch.
Minus 2x.
Plus,
Plus a blank.
Plus 1. I'm moving ahead.
and then those two.
So it
Pause. Focus. Luca. Shh. Go.
So you don't want necessarily to take off all the common factors, like the 16y squared and 64y.
We don't want to take out the y term because we want a trinomial inside that will become a perfect square. Does that make sense? So we're not solving for zeros. What we're trying to do is factor what we have. It's the focus. Anyone else who's distracted? So we're trying to make a perfect square trinomial. So to have that, we need the y squared, we need the y term, and then we're going to make the constant. How come 4?
What about 2 squared?
Yeah, cut the middle term in half and then square it. So 4 over 2 is 2 squared is 4. Fill it in and fill it in. What?
Okay, I'll multiply by 16 on the outside.
Remember? He's not just a 4. He's a 4 times 16. Then we're going to cut the negative 2 in half, and then we're going to square him. And Karina, you already said that's going to be a
1.
Got it. But why am I putting a minus?
Because the
negative
negatives
There's
were
a negative
outside
outside.
the parentheses.
Gotta check the outside, right?
Yes.
If nothing else, we can say we got down completing the square in pre-calc. Honors pre-calc. Okay, coming back. I think we have to factor some stuff, but hopefully, haven't we gotten a perfect square?
Yes, we.
The square root of 4 is 2. We've set it up ourselves. It's going to work out just fine. What's the second one going to be?
X minus 1.
Good job, guys.
Then we have negative 63 plus 64 minus 1.
0. Oh wait, no. 1.
Yeah.
A 0.
What's supposed to be there?
A 1. What happens now?
It's not a basic conic section. It's a.
For easy.
Someone read it. I think Eric read it. It wasn't one of the basics.
Degenerate.
It's a degenerate.
I don't remember
I thought he was gonna say
It's a degenerate one because where's the 1? It's gone. How do you get it there? You make magic? No, that doesn't work.
How do we get it there?
So who is this? If it's not a conic, it's not a hyperbola, it's not an ellipse, it's not a parabola.
It's a line.
Who is she?
It's a line.
How is it a line?
Oh.
It's 2 lines.
Oh!
Okay.
Because how would you
Oh.
solve this in standard form? I guess we can't really make a hyperbola anymore, so what if we move everything to the other side?
Ah!
Guys, I love this whole choosing your own seat thing, but we gotta focus when we need to. Otherwise it's not gonna last long. Can I plus or minus square root both sides now? That everything's all nice and fast.
Yeah.
Yes.
What do I get on the left? Plus or minus 4, y plus 2. What do I get on the right?
X minus 1.
Because this cancels, and then the square root of 16 when he becomes 4. And then if I divide both sides by a plus or minus, I know this is weird. But what ends up happening is y plus 2 equals plus or minus. I just move the 4 over.
Oh, okay.
I think this looks an awful lot like a line.
Point slope.
Point slope form, we can go straight to our line. Because we can see 2 things. We can see the slope and we can see a point. So, what's the point? 1 negative 2,
Yes.
y minus y1. So 1 negative 2. You guys crack yourselves up. Okay. What do I do with the slope?
Oh, you got 2 lines then, probably.
You have to go up 1 over 4, and that's going to be 1 line, right?
Okay.
But, question, don't I have a plus or a minus?
So that could be.
I'm going to go up 1 and back 4. Only I went up 1, that's nice. See how intersecting lines come from a degenerate conic? Hey look, just in time. Ready, set, and go.
Well, that's actually perfect timing. Thanks, guys.
Done, done, done.
We did it.
Pause! I know.
Ow.
Pause! If you were to graph a hyperbola in homework that wasn't degenerate, do you guys get that you would have to graph the center wherever it is? And the vertices wherever they're supposed to go? And then the foci wherever they're supposed to go? And then you just randomly swoopy swoop.
No.
Swoopy swoop.
No.
You go up and over and you make your your asymptotes, and then you swoopy swoop. And then you swoopy swoop. Make your asymptotes when you graph your hyperbolas. Bye guys.
Then you what?
Nicole, don't forget your phone. Last night, if anyone sees Nicole, I have her phone.
Let me see. Have a good rest of your day.